Welcome to Nihal Academy. This is your facilitator Pavan Kumar. Today we will discuss a small topic on electricity, that is series connection of resistors. So when the resistors are connected in series connection, what is series connection? The first resistor R1 first end is connected to the positive of the battery, and the second end of the first resistor is connected to the first end of the second resistor, and the second end of the second resistor is connected to the first end of the third resistor, and the second end of the third resistor is connected to the negative of battery through plug key. This type of connection is called as series connection. Now when the three resistors are connected in series, we will derive that resultant resistance. Now come to the point here, the ammeter is connected series in the circuit to know that current passing through that circuit, and voltmeter V1 is connected at R1 and voltmeter V2 is connected at R2 and voltmeter V3 is connected at R3 to know the potential differences at R1, R2, R3 respectively. And to close and on the circuit, we have connected that plug key, and the potential difference at the battery is V. So when the current passes, when we close the circuit, then current passes through the circuit and the current is I, it is moving from positive to negative. This is called as conventional current direction. So now the current I is remains same here. That means same current passes through the R1, R2, R3 respectively. So we can understand that here the current is constant. In series connection, current is constant. Now the potential difference is variating. So the potential difference at R1 is V1 and the potential difference at R2 is V2 and the potential difference at R3 is V3. Now the total potential difference at R1, R2, R3, it is equal to the potential difference at battery. So we can understand that, so potential difference is variating. So PD is variating, that means PD is changing. So we can write that the total potential difference at the battery V is equal to the sum of all the potential differences at R1, R2, R3 respectively. So V is equal to V1 plus V2 plus V3. As per Ohm's law, we know that V is equal to IR. Now apply this formula in this case, then V is equal to IR. V1 means voltage at R1, the potential difference at R1. So we know that V is equal to IR, that means the current passing through the R1 is I and the resistance is here R1. So IR1 plus V2, the potential difference at R2. Here the same current, so I, and the potential difference here V2 is at R2. So the R resistance is R2 plus the potential difference V3, that is at third resistor. So current I and the resistance is R3. So I R3. Now if you look at the board here, the current is constant. So we can take out common. Then I is equal to I1, I is equal to R1 plus R2 plus R3. If you look at the board, either side, the current I is constant, that remains constant, so equal we can cancel. Then R is equal to R1 plus R2 plus R3. So this is the net resistance or total resistance or equivalent resistance in series connection. So Rs is equal to R1 plus R2 plus R3. Now, if we generalize this formula for the n connections of resistors, then Rs is equal to R1 plus R2 plus R3 plus so on plus Rn. So we can understand that the resultant resistance or equivalent resistance or total resistance or net resistance in series connection, it is equal to R1 plus R2 plus R3. So subscribe, share, like the video. Thank you.